to meet you. I'm Justin Murray from Product Marketing Engineering. Used to be called Technical Marketing. I preferred Technical Marketing as a title at VMware, now Broadcom. And I've been in the company about 16 years or so, and I know some of you folks already. So what I'll do is give a brief, hopefully 15-minute introduction to what we're doing exactly with NVIDIA. Chris did a great job of introducing you to that architecture. I'm going to delve into it a little more detail here and give you some technical detail about it. So as you see, there are 4 layers here, if not more. The choice of models is at the top, and at the bottom you have various hardware vendors that have voted with their feet with this. They've already written deployment guides for NVIDIA AI Enterprise, which has been around now for 2 years, a software package that rides on top of VMware Cloud Foundation. What VMware Private AI Foundation is a further refinement of that, an addition to it, that's specific for large language models and Gen AI. And there are 2 main parts of that. The blue layer is a summary of the VMware offering. That's the add-on that the gentleman referred to on my left here earlier. That's an add-on to VMware Cloud Foundation, specifically for large language models and Gen AI. And I'm going to look at 4 things in there: deep learning VMs, the vector database PG Vector, which is the heart and soul of RAG, the self-service catalog, which to me is the nirvana of our solution here, which is give the data scientist the simplest possible way to get their tooling and platforms up and running quickly. Don't worry them about networking, don't worry them about disk space, just get their tools in front of them quickly. That's what that self-service catalog is all about. And that will remind you, I think, of public cloud offerings in LLMs, and that's deliberate on our part. We deliberately are doing something like that. Finally, there's GPU monitoring, which we give you in the vCenter interface so that you can see, is this data scientist hogging this GPU, or are they claiming they need 4 GPUs and actually using 1? That sort of thing. Above that is the green layer, we call it the NVIDIA layer, and there are a whole bunch of innovations on top of the products that you're seeing here coming soon from NVIDIA. So the answer to your question about deploying your model in a production-oriented world, in the NVIDIA world, that's Triton Inference Server, multi-threaded, multi-model, one per GPU type application server for models, effectively. And that presents an API called the gRPC API. The GPU operators we'll get into, those are Kubernetes things. Kubernetes is very much in the picture here when you go into production. The NeMo framework, NeMo in NVIDIA terminology stands for neural modules. Neural networks are, of course, and transformers are at the heart of all this work. And then TensorRT is an optimizing compiler for your model to say, well, you started off with 32-bit word size. I'm going to take you down to 8-bit word size before you go to production, because that's going to give you a much slimmer model. And I'll do a demo of some of these things coming up soon. So that's our high-level architecture with NVIDIA. Now, as Chris pointed out, there are other architectures with other vendors as well. This is one of a set. And I'm going to get into this.
So Justin, does the NVIDIA Private AI solution work with the open source language model?
Yes, it does. So I'm going to show you Llama 2, for example, downloaded from Meta and running.
Had their own large language model.
And you're absolutely right. NVIDIA has their own large language models under the banner of NeMo there. So you may have heard of Megatron. That's their name for their high-end model. So they have a whole series of these, some of them even customized for specific GPUs. And I've used one of those in the demo here. Thank you for that question. So for me, the highlight, which I'm doing first deliberately, is the self-service catalog. And that is based on ARIA automation, one of the VMware Cloud Foundation tools, particularly a service broker within ARIA automation that allows you to construct these tiles in front of you. And this I expect to put in front of a data scientist or an administrator serving a data scientist. And this is being pre-built by somebody who knows ARIA using wizards to do that. We've given you wizards to do that. And so the data scientist would...
Justin, just to clarify, so when you say an administrator, are you talking about DevOps? Are you talking about platform?
Yes, a DevOps person, a platform engineer, perhaps somebody who's running in Kubernetes all day long, but now wants to provide a friendly user interface to the data scientist.
Right,
That
so
type
that's your
of person.
target persona for this.
Two personae here. One is the data scientists themselves. We could put this in front of them, or somebody who serves the data scientist with this platform.
Okay, thank you.
Right, both cater for here, and you'll see more of the detail.
But Justin, is this something that could be driven through APIs, or is it just a GUI interface?
It certainly has an API, and we can make use of that. I'll show you a little more about that in the demo section.
So the DevOps people could use the APIs to drive and fire up a Kubernetes cluster.
Absolutely right. Yeah, and that particular API that you're referring to bring up a cluster we call the Cloud Consumption Interface, CCI. You'll be seeing that in the demo in a few minutes here. So just stick with me that the data scientist wants the simplest thing possible to do, and I'll get into this in great detail in the demo. And they make a choice, actually. They may choose, I want the simplest possible workstation, I just want one VM to work on, or I want a whole Kubernetes cluster to work on. Underlying those, in the background, are things called deep learning VMs, which we're going to ship to you. We're going to ship to you in OVA format. OVA is Open Virtualization Architecture. This is a packaging mechanism for shipping out a VM to you. So you're going to get a set of these from us as part of the Private AI Foundation with NVIDIA. And in those VMs are various data science toolkits, simplest one being TensorFlow or PyTorch, which I'm going to show you in a few seconds. But of course, a data scientist is going to be using a Jupyter notebook. Everybody's using a Jupyter notebook now with Python in it to do data science. You might want to virtualize that using Conda, a Docker engine just to run individual containers, or a Kubernetes around all this to run multiple containers, of course. The point, though, is there are pre-made, opinionated deep learning VMs, and you can create one of these. It's fairly easy to create one. There are pre-made ones coming from VMware here in this offering.
How are they updated? Are they pushed down? Obviously, this world's changing relatively quickly. Are they updated from a VMware global catalog on a cadence?
Correct. We will maintain these. We will update them. We will patch them, and then we'll keep them in the repository where you can get them. I actually downloaded them into my vCenter when I was bringing up the demo, and you'll see that in a few seconds. So we've had quite a bit of discussion already about vector databases. We see this as the heart and soul of retrieval augmented generation. Retrieval is the database part. Augmentation is the model part. It's a database and a model working together to answer your question better, is how I think of retrieval augmented generation. And I'm going to go into the details there to give you a little more on that. The reason we're focused so much on this, and I think of it as one type of fine-tuning. Fine-tuning has many different instantiations like prompt tuning, p-tuning, applying some extra data to your model. But vector databases and RAG present themselves, and we've heard this from different sources, present themselves as an easy on-ramp to doing LLMs and doing this large language model work. And so what that looks like, and this looks more complicated than it really is the user is using a client application here like a chatbot. And that person puts in their question into the chatbot, and that becomes a prompt. Now, prompts don't go in English to the database or anything like it. A prompt is a sentence. It's broken up into words. That's called tokenization. Those tokens are then converted into numeric values called embeddings. All of that is done by a different model to our large language model on the right-hand side. All of that is done by something called an embedding model that understands your question and translates it into numbers effectively. And those numbers go off to the vector database, and not shown on my diagram is the loading up of my private files, my private data, into that vector database ahead of time. That too will involve the embedding model because my private files are written in English or HTML, and they'll be loaded into the database ahead of time. So my query goes off to the database and says, tell me everything you know about vSphere 8 Update 3, which, by the way, hasn't shipped yet. And so it's private. It's private data to us. And that vector database is capable of doing similarity searches that says, this person is obviously interested in vSphere 8 Update 3. Do I have any documents indexed in my data that refer to that subject? And of course, we've loaded our internal data in there, so it has something. So it returns then the index documents back to the client application, and the client application says, well, okay, this is a lot of documents, this is a lot of material. I'm going to send that to my large language model for summarization. So then the results from the database are sent over into the large language model, which processes them and presents a nice summary back. So you're sitting in a contact center somewhere, and the customer's on the line saying, what are the features of vSphere 8 Update 3? And the person sitting beside you doesn't know. You go to your large language model, you say, what are the features of vSphere 8 Update 3, which is a few months out, and the model comes back to you and says, here's a list of features. Contact center resolution. Helping a customer with a question that they can't get the answer to on the web, or they can't get it from an existing model.
So this is I'm sorry, this
Go
is a super critical process of adopting LLMs within a large enterprise. So let's say I'm a financial services company and I have large language model, I'm doing whatever. And I have a bunch of advisors who are going out to individual clients. Now I can create unique databases or unique RAG instances, vector databases, and for each model, for each client. So when they say, hey, what's my tax burden if I was to do X, Y, and Z based on our historic processes, now I can do that in a very private manner, potentially even on a laptop, depending on how big the model and the parameters.
Yeah, up to the laptop point, I was with
No,
you.
I gotta push.
Probably in the future on the laptop, yes. But a financial advisor using private data, private reports from their financial institution that are not public, loaded into that database can give that client some answers. Yeah, that's the idea.
Sorry, and then in this example today, your vector DB is any vector DB or specific one, a limited set?
As you heard from Chris before me, we're pretty open-minded here.
Okay.
I'm going to show you an open source vector database, but we have a specific offering in the vector database world here, which
Perfect.
you've given me the perfect segue to, which is
You're welcome.
PG vector. Thank you. Now, one last point on this. If this is based on database technology on which we can secure using encryption, using role-based access control, all the better, right? Because that's private data. That's my private banking reports that are not visible in the outside world. So we are working with Postgres, an already existing database with encryption, with role-based access control to the data, so that you can really feel that this data is private. And we're putting a layer on top of that. Think of that PG vector entry there as just a container. It's a container that you fire up using Docker or Kubernetes, and it connects up to the Postgres, and it gives you the vector interface. The vector interface is similarity search. Here's a subject, vSphere 8 Update 3. Tell me any documents that are similar to it. And we will provision that using something called Data Services Manager, which is a tool within VMware Cloud Foundation that looks like this. So here I've asked my friend Michael West to present me a Postgres database ready for connection into PG vector container, ready for use as a vector database here. And this tool, by the way, provisions lots of different databases, not just Postgres. Go ahead, Gina.
Pipe dream. This is a problem we have lived together during a launch. So how hard is it, talk properly, how hard is it to get the private data and turn it into public data? So like if I wanted to run a launch, it would seem like we could work on this private data until it was time to make it all public to the data, to the available to the public. But then we would have to change the data into public data versus private data. We could just say, give me all the documents for the launch coming up Wednesday, and they would all appear and we wouldn't have to do any other work. It would be beautiful.
Yeah.
So is that possible to change the private data to public data that easily, or is it going to be a?
It is indeed possible. And if you look at the large language model on the right-hand side there, the reason we added the vector database is because that large language model was trained 2 or 3 months ago. It didn't see my private data 2 or 3 months ago. Now I can, in the background, retrain that model, a different version of it, retrain that model in data that's about to become public the day before launch, and put that model into production with suitable testing.
Beautiful.
Now I don't need the RAG database because my model's up to date. But a couple of days later, the model's out of date. So this model gives me two benefits. One is my data is as up to date as the vector database contents. And secondly, the model is still active here. It's still processing the words that are being fed back to it. And it's private. It's held privately. So
you're using Postgres. Why not Greenplum from the Tanzu family?
Absolutely. Thank you. Greenplum is a distributed form of Postgres. Multiple Postgres running in parallel. There's no reason we couldn't do that. The first iteration of our private AI product will be Postgres. No doubt we'll go ahead and do it in a distributed fashion later.
Justin, I got a question. This is outstanding. I like the way you're describing this, but I also have a sense of feeling very academic. And what would be interesting to understand from a VMware perspective is your customer use cases, the customer data that's using it today versus the ones that want to use it, the demands coming in, asking for it, and where do you see the market going?
I had a customer, a very large bank, call us last week and said, we want to do RAG with vector databases.
Right.
We're a bank, we have private data. We want to supply a chatbot to our teller, not just teller people, but representatives in general, to answer questions from customers. So that's just one of a series of customers that are having conversations with us about this architecture.
Have you done analysis internally to understand the scope of the demand for it?
Other people other than my department have.
Okay.
I don't have that data
That's
personally.
fair. It's just it's something that would be helpful in this conversation to understand that, because we can all build great technology stacks.
Yes.
But if nobody's buying it and if nobody's using it.
Understood. Yeah. And it's not just us that's favoring this particular architecture. If you speak to NVIDIA, they'll also say RAG is a hot topic out there. If you go to the GTC conference coming up in March, for example, I've already looked on the catalog. There are close to 20 talks on this.
Right.
So it's popular. It's popular. So
is more than 60 customers globally, and that's without even a GA product to sell yet. So it's substantial. It crosses industries. Their most common use case is RAG with some type of chat interface for private data X, essentially.
That's helpful to start this conversation.
Okay.
yeah. And, we're going to provide lots of guidance as well. Part of that guidance fits into this tool within the VMware Cloud Foundation, which is the foundation of all this, is the SDDC Manager. SDDC Manager, to me, is a bit of a frightening tool because it deals in hundreds of servers, thousands of servers. Very large enterprises use this to split up their VMware landscape into workload domains, a marketing workload domain, a business intelligence workload domain. And that's part of the separation of concerns that we see with different users using this. So we're going to give you deployment guides, instructions, quick start guides on how to do all the steps that I'm talking about here, such as deploying a deep learning VM, building up a vector database. There's going to be specific instructions inside the tool itself for doing this. Last topic, GPU monitoring. Okay, we've satisfied our data scientists. We've given them the tooling and the platforms that they want. They've built their models. They're using the models. The models are going to inference. What's happening in the infrastructure? What's going on? And what we'd like to be able to show you is right at the top of our performance priorities are CPU consumption and memory consumption. But now, alongside those on the priority list are GPU compute consumption and GPU memory consumption, because these are expensive devices. High-end H100 device is an expensive one. We want to ensure that this is being used to its best potential. So rather than giving you more academics, I'm now going to give you practice. I'm going to show you this operating in real life. Before I do that, I'll just mention briefly some of the NVIDIA components. The GPU operator has been around for a couple of years now. I used it when it was at version 0.1. It's a wonderful tool because when you use the NVIDIA stack, you've got two drivers that you need to take care of. One driver goes into ESXi, another driver goes into each of your VMs that are running GPUs against it. The GPU operator, in a Kubernetes context, says, let me take care of those drivers for you. Let me install the guest driver. I will manage its health, and I will run it in pods on Kubernetes for you. You don't need to install it in the guest operating system anymore. This astounded me when I saw it first, because I had spent years installing those drivers, time after time after time into VMs. I plug in the GPU operator. I say, this is my Kubernetes cluster. Here are the GPUs I want. It does the rest. It simplifies my life as a manager of such things. The question came from the gentleman on my left. How does this look at inference time? Inference time, as Chris pointed out, is the payoff of all this. Training time is the investment. It's the development. Inference time is production. And you want production to be scalable. And NVIDIA's Triton inference server does just that. I deployed across 2 GPUs, for example. It put a Triton inference server on each of them. It's model driven. That's important because I want to have a repository of models with different versions, different data sets that apply to them. There's not just going to be one model, as Chris pointed out. There's going to be dozens, if not hundreds of models in organizations. You're going to need to control those models, and MLOps vendors do that, but they require a repository. And so what NVIDIA has done here is created a highly scalable inference server with an API that you can access your models through the API or through client applications. And the client applications are sitting on the right-hand side here. They're inserting queries, making questions. The appropriate inference server is going to take that question. Not all of them need to take it. One of them will take it and then pass it on and execute the model on your behalf.
What guardrails can be enabled, or is that really up to the application owner to stick something in front in terms of throttling so they're not saturating, per model or whatever?
Yeah, the guardrails question is a great question. There is NVIDIA technology to do guardrails that can be added into this suite. I don't show it here, but they can prevent bias. They can at least address bias. They can find sort of denial of service attacks and dismiss those. They have a whole bunch of best practices and technology actually that will protect your model from attack.